What if I told you that darkness isn't just the absence of light, but might actually be the fundamental state of reality itself? What if darkness came first, and light is the anomaly, the exception, the brief flicker in an ocean of eternal shadow? Before there were stars, before there were galaxies, before there was even the concept of before, there was darkness. And here's what will absolutely shatter your understanding of reality. Darkness might not just be older than light. It might be eternal, uncreated, and waiting patiently for light to burn out so it can reclaim everything that ever was. In the next 3.5 hours, I'm going to fundamentally change the way you understand existence itself. We're going to explore a question so profound that it touches quantum mechanics, cosmology, thermodynamics, philosophy, and the very nature of time. By the end of this journey, you'll never look at shadows the same way again. You'll understand why the darkness you see when you close your eyes might be showing you the truest face of the universe. Here's the mind-blowing part that scientists don't often talk about. When you turn off all the lights in your room, you're not creating darkness. You're revealing it. Darkness was always there, patient, persistent, fundamental. Light is what we have to create, to generate, to fight for. And every single photon of light that has ever existed is on a one-way journey back to darkness. But before I reveal the shocking answer backed by cutting-edge physics and cosmology, I need you to do something. If this question has already grabbed your attention, hit that like button right now. Subscribe to this channel because we're about to go on a journey through space, time, and the fundamental nature of reality. And I'm curious, drop a comment telling me what country you're watching from and what time it is where you are. Are you watching this in daylight or in darkness? Because that answer might matter more than you think. Let me start by telling you about James Clerk Maxwell, the Scottish physicist who, in 1862, unified electricity and magnetism and discovered something extraordinary. Light is electromagnetic radiation. But here's what kept Maxwell up at night, what he wrote about in his private letters. If light is a wave that propagates through space, what happens to the space when there's no light? Is darkness merely absence, or is it presence? Maxwell died without answering this question, but his equations hinted at something unsettling. The mathematics of his electromagnetic theory didn't require light to exist. The universe was perfectly fine, mathematically speaking, in complete darkness. Light was the add-on, not the foundation. Now, I know what you're thinking. This is just semantics, right? Darkness is just what we call it when there's no light. But what if I told you that modern physics has discovered something that would make Maxwell leap from his grave? What if darkness has properties, behaviors, and effects that exist independently of light's absence? Stay with me, because in about 8 minutes, I'm going to show you experimental evidence that darkness can do things that light cannot. Think of it like this. Imagine you're standing in a completely sealed room with a bucket of water. You can pour the water out, splash it around, watch it flow. Now imagine someone tells you that the air in the room isn't real. It's just the absence of water. You'd think they were insane, right? You can feel the air. It has pressure, it has properties, it exists. What if our understanding of darkness is the same kind of fundamental mistake? What if we've been defining darkness by what it isn't, instead of understanding what it is? Here's your first mind-blown moment. In quantum field theory, the vacuum of space, what we think of as empty darkness, isn't empty at all. It's seething with virtual particles popping in and out of existence. The darkness contains energy. In 1948, Dutch physicist Hendrik Casimir predicted that two metal plates placed close together in a vacuum would experience an attractive force because the darkness between them contains less energy than the darkness outside them. This is called the Casimir effect, and it was experimentally confirmed in 1997. Read that again. Darkness has measurable energy that creates physical forces. Darkness isn't nothing. It's something. But we're getting ahead of ourselves. To really understand whether darkness is older than light, we need to go back, way back, to the beginning. And here's where things get really strange, because when we talk about the beginning of the universe, we run into a problem that most people don't know about. The Big Bang Theory doesn't actually describe the beginning. It describes what happened after the beginning. There's a gap, a mysterious period that physicist Alan Guth calls the ultimate free lunch. And in that gap, in those first incomprehensible fractions of a second, darkness and light hadn't been invented yet. Let me take you there. Imagine it's 13.8 billion years ago. Actually, don't imagine. Let's be precise. It's 13,799,000,000 years ago. Give or take 21 million years. We're going to rewind the universe like a film in reverse. Galaxies rush toward each other. Stars unexplode. The universe gets hotter, denser, more cramped. We pass the point where atoms can exist. Electrons are stripped away by the sheer energy. We pass the point where even atomic nuclei can survive. Protons and neutrons are torn apart into quarks. We're now at 1 microsecond after the Big Bang. The universe is a roiling soup of fundamental particles and radiation. And yes, light exists here. Photons are everywhere. But keep rewinding. We hit 10 to the negative 43 seconds after the Big Bang. This is called Planck time, the smallest measurement of time that has any meaning. This is where physics breaks down, where our equations start dividing by zero and spitting out infinities. And here's the question that will haunt you. What's on the other side of Planck time? What existed at time equals zero? And here's the shocking answer. We don't know. We can't know. Our physics doesn't work there. But here's what we do know. If there was a moment of absolute beginning, before that moment, there was no light. There couldn't be. Light requires space and time to propagate through. Before space-time, there was what? Most physicists would say, nothing. But what does nothing look like? Close your eyes. That's closer to what nothing looks like than any description I could give you. That darkness, you see? That's closer to the primordial state of reality than the brightest star. And here's where your mind should start bending. If there was ever a state of absolute nothing, a state before the universe, that state wasn't temporary. That state of nothing, of darkness, of non-being, it's eternal in the backward direction. There was never a time when it began, because time didn't exist. Darkness, in this sense, has no age. It's beyond age. It's the default state of non-existence from which existence had to claw its way out. But light? Light has a birthday. We can calculate it. The first photons that could travel freely through space were born about 380,000 years after the Big Bang, during an event cosmologists call recombination. Before that, the universe was opaque. Photons couldn't travel because they kept bouncing off free electrons. The universe was bright, but not illuminated. Think of it like being inside the sun. Light everywhere, but you can't see anything. Then, as the universe expanded and cooled, electrons and protons combined to form neutral hydrogen atoms. Suddenly, photons could travel. The universe became transparent. Light, as we understand it, as something that illuminates, that travels, that can be seen, was born in that moment. We can still see this ancient light today. It's called the cosmic microwave background, and it was discovered by accident in 1964 by Arno Penzias and Robert Wilson, two scientists at Bell Labs who thought they had pigeon droppings interfering with their antenna. They won the Nobel Prize for finding the oldest light in the universe, light that has been traveling for 13.8 billion years. Light that is now stretched into microwaves by the expansion of space itself. This is light's birth certificate. We know when it was born. Darkness has no such certificate. And here's your next mind-blown moment. Darkness might not need one. If darkness is the default state, the ground state, the inevitable equilibrium of reality, then asking when darkness began is like asking when emptiness began. It's a category error. Darkness didn't begin. Everything else began against the backdrop of darkness. Now, before we go deeper into the physics, I need you to do something. If your mind is already spinning with these ideas, if you're starting to question everything you thought you knew about reality, hit that subscribe button. Because we're only 15 minutes in, and I'm about to show you why the darkness in your room right now is connected to black holes, quantum mechanics, and the ultimate fate of everything that exists. And drop a comment, tell me if you're watching this with the lights on or off. Because by the end of this video, you might have a very different feeling about sitting in the dark. Let's talk about what light actually is, because most people have a completely wrong understanding. You probably learned in school that light is both a wave and a particle, right? Quantum mechanics, wave-particle duality, all that strange stuff. But here's what they don't tell you. Light is fundamentally a disturbance. Think of it like this. Imagine a perfectly still pond. That's darkness. That's the vacuum. That's the ground state. Now throw a stone in. The ripples spreading out? That's light. Light is a disturbance in the electromagnetic field. It's a deviation from equilibrium. And what does every disturbance eventually do? It settles. It returns to stillness. It returns to darkness. This isn't philosophy. This is thermodynamics. The second law of thermodynamics states that entropy always increases in a closed system. Disorder always increases. Energy disperses. Concentrated forms of energy, like light, always spread out, dilute, and eventually dissipate into the heat death of the universe. Every photon ever created is on a one-way journey toward becoming part of the low-energy background radiation that will eventually define a cold, dark, dead universe. Light is temporary. Darkness is patient. Here's a thought experiment that will mess with your head. Imagine you could watch the entire history of the universe as a time lapse from beginning to end. For the first 10 billion years or so, you'd see what we call the stelliferous era, the age of stars. Galaxies forming, stars igniting, light everywhere. Beautiful, luminous, bright. But this era represents only about 0.00000000001% of the universe's total lifetime. Yes, you read that right. If the universe lives for 10 to the 100 years, and that's conservative, then the age of light, the age we live in, is a brief flicker. After the stars burn out, after the last red dwarf gutters and dies in about 100 trillion years, the universe enters the degenerate era, then the black hole era, and finally the dark era. These dark eras don't last billions of years. They last numbers of years, so large we don't have names for them. YY years, 10,100 years, 1,010,120 years. From the universe's perspective, light is a brief aberration, a temporary fever, a moment of excitement before the long, eternal return to darkness. If the universe were a human lifetime, the age of stars would last less than one heartbeat. Darkness is the childhood before birth and the endless old age after death. Light is the brief, bright moment in between. But here's where it gets even stranger. Let's talk about what darkness can do that light cannot. In 1974, Stephen Hawking discovered something that shocked the physics world. Black holes emit radiation. Now, black holes are the darkest objects in the universe. Light goes in and never comes out. They're literally holes in space-time where light goes to die. But Hawking showed that due to quantum effects at the event horizon, black holes slowly evaporate, emitting what's now called Hawking radiation. And here's the kicker. This radiation comes from the darkness around the black hole, from the quantum vacuum, from the nothingness that surrounds the event horizon. Darkness is creating light. Think about that. At the edge of the darkest object in the universe, darkness itself generates light through quantum processes. The vacuum, the darkness, the nothing, it has the power to create something. But light can't create darkness. Light can only fail, dissipate, be absorbed. Darkness is generative. Light is consumptive. Now I want you to do an experiment right now. Close your eyes. Keep them closed for 10 seconds. I'll wait. What do you see? You see phosphene's random patterns of light created by your visual neurons firing. Your brain is so wired to see light that even in complete darkness, it generates phantom light. You literally cannot perceive pure darkness with your eyes. Even when no photons enter your eyes, your visual system creates light from neural noise. This tells us something profound about our relationship with darkness. We are terrified of it. We're so afraid of darkness that our brains hallucinate light rather than confront the void. But darkness is always there, behind the hallucinations, patient and real. And here's your third mind-blown moment. Darkness is faster than light. That sounds insane, right? Nothing can travel faster than light. Einstein proved that. But watch this. Imagine you have a flashlight in a completely dark room. You turn it on. Light travels from the flashlight at 299,792,458 meters per second, illuminating parts of the room. Now you turn the flashlight off. How fast does darkness return? Instantly. The moment the last photon is absorbed or leaves the space, darkness is there. Darkness doesn't travel. It doesn't need to. It's already everywhere, waiting. Light has to propagate. Darkness is omnipresent. You might argue that darkness returning is just light leaving, so it's still limited by the speed of light. But consider this. Imagine you create a shadow, a light year across. You do this by putting a massive object between a distant star and an observation point. Now you move that object. The shadow moves. And here's the thing: the shadow can appear to move faster than light. This doesn't violate relativity, because shadows don't carry information or energy. They're not things moving. They're the absence of things. But it demonstrates that darkness operates under different rules than light. Darkness is the canvas. Light is the paint. Let me tell you about an experiment that changed everything. In 2013, researchers at the University of Cambridge created what they called artificial darkness, using materials engineered at the nanoscale to have properties not found in nature. They created a substance that didn't just absorb light. It trapped it so completely that it became the darkest material ever made, absorbing 99.965% of visible light. They called it Vantablack. When you look at something coated in Vantablack, your brain can't process it. It looks like a hole in reality. You can't perceive depth, shape, or form. It's not black like paint is black. It's the absence of visual information. But here's what's truly bizarre. The scientists reported that creating Vantablack was easier than creating a perfect light source. Making something perfectly dark requires less energy and less precision than making something perfectly bright. Nature tends toward darkness. We have to fight for light. Now we need to talk about something uncomfortable: the heat death of the universe. This is the ultimate fate of reality, according to our best physics, and it's all about the triumph of darkness. Roger Penrose, who won the Nobel Prize in 2020 for his work on black holes, has calculated the ultimate endpoint of universal evolution. In about 10,106 years, every black hole in the universe will have evaporated through Hawking radiation. Every star will have burned out. Every atom will have potentially decayed. What's left is a universe in perfect thermodynamic equilibrium, maximum entropy, minimum energy density, absolute darkness. Not the darkness of a room with the lights off. The darkness of a universe where the concept of light has become physically impossible. And here's where it gets philosophically heavy. That state of maximum entropy, of absolute darkness, that state is eternal. Once the universe reaches heat death, it stays there forever. Infinity. The age of light lasts maybe 100 trillion years. The age of final darkness lasts forever. So when we ask, is darkness older than light? We have to also ask, what's going to outlive what? And the answer is unambiguous. Darkness wins. Darkness always wins. But let's rewind to the beginning again, because I want to blow your mind one more time before we move to the next section. Cosmologists have a concept called conformal cyclic cosmology, Penrose's idea that the heat death of one universe might be the Big Bang of the next. The idea is that when the universe reaches maximum entropy and darkness, all sense of scale disappears. An infinitely large, dark, dead universe is mathematically indistinguishable from an infinitely small, dense point. The end becomes the beginning. And if this is true, if universes cycle through big bangs and heat deaths eternally, then darkness isn't just older than light. Darkness is the womb from which light is born and the grave to which it returns, over and over, forever. Think of it like this. You know how the ocean waves crash on the shore, pulling back, crashing again, eternally? Imagine darkness as the ocean, vast, deep, ancient, eternal. Light is the foam on the waves, beautiful, visible, ephemeral. We live on the foam. We are made of foam. We celebrate foam, study foam, love foam. But the ocean is always there, infinite and patient, and the foam always returns to it. Are you still with me? If your concept of reality is starting to shift, if you're feeling that vertigo of understanding something deep for the first time, good. That's exactly where you should be. Hit that like button if this is scratching your brain in the best way possible. And subscribe, because we're about to go even deeper. We're going to explore the quantum mechanics of darkness, the philosophy of nothingness, and why ancient mystics might have understood something about darkness that modern science is only now confirming. Let me tell you what's coming in the next section. We're going to explore what happens when you try to remove all light from a space truly all light down to the quantum level. And we're going to discover that you can't do it. The universe won't let you, because darkness at the quantum scale is something that will fundamentally change your understanding of nothing. But first, let's establish something crucial. What is light, really? At the most fundamental level, light is quantized packets of electromagnetic energy called photons. They have no mass. They always travel at the speed of light in a vacuum, and they're both waves and particles, depending on how you observe them. Photons are created when electrons and atoms drop from higher energy states to lower ones, releasing the energy difference as light. Every light bulb, every star, every firefly, they're all doing the same thing, exciting electrons and harvesting the photons they emit when they relax. But here's the question that should bother you. Where do the photons go when they're absorbed? When light hits your retina and you see something, that photon is destroyed. It ceases to exist. Its energy is transferred to electrons in your retinal cells, starting the cascade of neural activity that becomes vision. The photon is gone. And here's the profound part. Every photon will eventually be absorbed, every single one. There are approximately 1,090 photons in the observable universe right now. In the far future, that number will be zero. Not approximately zero, actually zero. Light is being consumed by darkness at every moment. Every surface that absorbs light, every eye that sees, every solar panel that generates electricity, they're all agents of darkness, destroying photons and returning their energy to the dark equilibrium of the universe. We think of ourselves as beings of light, but we're actually beings of darkness. We consume light to live. We destroy photons with every glance. Now let's talk about the cosmic microwave background again, because it holds a secret that most people don't know. That ancient light from 380,000 years after the Big Bang, that light that's been traveling for 13.8 billion years, it's dying. The expansion of the universe is stretching the wavelength of every photon, redshifting it to lower and lower energies. In the incomprehensibly far future, those photons will be redshifted so severely that their wavelength will be larger than the observable universe. At that point, does the photon even exist? What does it mean for a wave to have a wavelength larger than space itself? The universe is killing light through expansion, stretching it until it becomes indistinguishable from nothing, from darkness. Here's your fourth mind-blown moment. There's a theory in cosmology called eternal inflation. proposed by Alan Guth in 1979 and refined over the decades. It suggests that the Big Bang that created our universe isn't unique. Instead, the inflationary field that caused space to expand exponentially in the first fraction of a second is still inflating in other regions of the larger multiverse. Universes are constantly budding off like bubbles in an infinite ocean of dark energy. And here's the thing, that dark energy, that inflationary field from which universes are born, it's called dark energy for a reason. It's not made of photons. It's not light. It's something else, something that fills the space between universes, something that exists in the darkness beyond reality itself. If eternal inflation is correct, then the multiverse is an infinite dark ocean with occasional bubbles of light universes like ours, where physical laws allow for the temporary existence of stars and photons. But the ocean, the darkness, the inflationary field, it's eternal, infinite, and it was never created. It just is. Darkness, at the multiverse scale, isn't just older than light. It's the eternal substrate from which all light temporarily emerges. But let's come back to something more tangible. Let's talk about what happens in the darkest places humans have ever created. There's a facility in Minnesota called the Sudang Underground Laboratory, built in an old iron mine, half a mile underground. Scientists go there to study things that are so sensitive to light and other radiation that they have to be shielded by half a mile of rock. In those chambers, the darkness is so complete that if you turn off all the equipment and lights, you experience a darkness that no human in evolutionary history was meant to experience. People who have been in that darkness report something strange. After about 30 minutes, they start to hallucinate vividly. Their brains, desperate for sensory input, create entire worlds of light and vision from nothing. The darkness drives them temporarily mad. This tells us something about consciousness itself. We are not built for darkness. We are creatures of light, living in a universe that is fundamentally dark, and our minds rebel against confronting that truth directly. But those scientists aren't studying darkness for fun. They're searching for dark matter, another form of darkness that outweighs all the visible matter in the universe by a factor of 5 to 1. Fritz Zwicky first proposed dark matter in 1933 when he noticed that galaxies and clusters were moving too fast to be held together by the gravity of visible matter alone. There had to be something else, something invisible, something dark. And we now know that about 85% of all matter in the universe is this dark matter. We don't know what it is. We can't see it. It doesn't emit, absorb, or reflect light. It's matter that exists in total darkness, detectable only by its gravitational effects. Then there's dark energy, which makes up about 68% of the total energy content of the universe. It's causing the universe to expand faster and faster, pushing galaxies apart, eventually dooming them to isolation as the space between them grows faster than light can cross it. And we have no idea what dark energy is. None. We just know it's there, invisible, dark, powerful, and it's tearing the universe apart. Let me hit you with a number that should shake you. 95% of the universe is dark. Only 5% is the normal matter made of atoms that can interact with light. Everything you've ever seen, every star, every planet, every galaxy visible to our most powerful telescopes, that's the 5%. The 95% is darkness of a kind we don't even understand. When we look at the universe, we're not seeing reality. We're seeing the tiny, anomalous fraction that happens to glow. The real universe is dark, and it's always been dark. Now let's talk about speed again, but from a different angle. Light takes time to travel. When you look at the sun, you're seeing it as it was 8 minutes ago, because that's how long it takes light to travel 93 million miles. When you look at the nearest star, Proxima Centauri, you're seeing it as it was 4.24 years ago. When you look at the Andromeda galaxy, you're seeing it as it was 2.5 million years ago. Light carries the past. Darkness carries the present. When you see darkness between the stars, that darkness is now. It's not delayed. It's immediate, eternal, present. Here's something that will bend your mind. Because light has finite speed, but darkness is already everywhere. Most of the universe exists in a state you will never be able to see. There are galaxies so far away that their light will never reach us because the space between us and them is expanding faster than light can cross it. We are surrounded by an invisible universe, a dark universe, forever beyond our ability to illuminate. The darkness that surrounds us isn't just vast, it's mostly unknowable. Let me tell you about an experiment you can do right now. Find the darkest place in your home. Turn off all lights. Cover all windows. Seal every gap where light might leak in. Let your eyes adjust for 20 minutes. You still won't see true darkness. Your eyes will generate phantom light. The walls, if they're not at absolute zero, will emit infrared radiation. Cosmic rays from space will strike your retinas, creating flashes of light. The bioluminescent bacteria on your skin will glow faintly. Perfect darkness is impossible to experience on Earth. Even in the deepest caves, radioactive decay in the rocks produces faint light. Even in the depths of the ocean, bioluminescent creatures glow. Darkness, true darkness, is something humans have never experienced. But the universe has. Before recombination, before the first stars, the universe was dark for 380,000 years. Not the darkness of night, but absolute darkness. No photons could travel. And after the last star dies in 100 trillion years, the universe will return to darkness for the rest of eternity. We exist in the infinitesimally brief moment when the universe is experimenting with light. Here's your next mind-blown moment. Consciousness might require light. Every thought you have, every memory, every sensation depends on neurons firing. And neurons firing depends on electrochemical gradients maintained by energy from food. And that food energy comes from sunlight captured by photosynthesis. You are a machine that converts light into thought. When the last stars die and the universe goes permanently dark, will consciousness still be possible? Or is consciousness itself a temporary phenomenon? A brief complexity enabled by the energy density of stars, destined to disappear back into the darkness forever? Some physicists think consciousness might survive through artificial means von Neumann machines, quantum computers running on the faint energy of black hole evaporation. But even those will eventually run out of energy. There's a concept called the final anthropic principle, proposed by physicist Frank Tipler, suggesting that intelligence might find a way to continue thinking even as the universe approaches heat death, by using less and less energy and thinking slower and slower thoughts. But even if that's possible, those thoughts will happen in darkness. The last conscious thought in the universe will occur in absolute, total, eternal darkness. And after that thought, nothing, forever. Are you feeling it yet? The weight of darkness? The reality that we live in a brief bubble of light surrounded by infinite darkness in both space and time? If you are, good. That's understanding. That's seeing reality clearly for the first time. And if this is resonating with you, if you're hooked on this journey, make sure you're subscribed, because we're going to go even deeper into the quantum strangeness of darkness and what it means for your existence. In the next section, we're going to explore what happens at the absolute bleeding edge of darkness, the quantum vacuum, the zero-point energy, the place where darkness becomes weirder than anything you can imagine. We're going to discover that the darkness isn't empty. It's full of potential, full of virtual particles, full of information. And that discovery is going to make you question whether darkness is actually the more real state of the universe. But before we get there, let me plant a seed in your mind. What if light is the illusion and darkness is the truth? What if everything you perceive is a temporary distortion in an underlying dark reality? Hold that thought. We're going to return to it, and when we do, it's going to change everything. Let's dive into quantum mechanics, because this is where darkness stops being the passive absence of something and becomes actively strange. In classical physics, the physics of everyday experience, darkness is simple. It's just the absence of photons. No light sources, no photons, darkness. Simple. But quantum mechanics says no. Actually, it's not simple at all. In fact, quantum mechanics says that empty space, perfect darkness, is one of the most complicated and energetic things in the universe. Here's the setup. Imagine you could create a perfect vacuum. You remove all matter, every atom, every particle. You remove all light, every photon. You cool it to absolute zero, no thermal radiation. You've created perfect darkness, perfect emptiness, right? Wrong. According to quantum field theory, that empty space is seething with activity. The Heisenberg uncertainty principle states that you cannot know both the energy of a system and the time interval in which you measure it with perfect precision. This means that for very short periods of time, energy can fluctuate from nothing. These fluctuations create particle-antiparticle pairs that pop into existence from the vacuum, exist for a tiny fraction of a second, and then annihilate each other. This happens constantly, everywhere, in every cubic centimeter of space. Virtual photons, virtual electrons and positrons, virtual quarks, they're all appearing and disappearing from the darkness constantly. The vacuum isn't empty. It's a bubbling foam of quantum possibilities. Darkness isn't nothing. It's everything that could be, but isn't yet. This was predicted theoretically, but seemed impossible to test until Casimir came along in 1948. He realized that if the quantum vacuum has energy, that energy should have measurable effects. He calculated that two uncharged metal plates, placed very close together in a vacuum, would experience an attractive force. Because the quantum fluctuations between the plates would be restricted, only certain wavelengths would fit, while the fluctuations outside the plates would be unrestricted. The darkness inside pushes less than the darkness outside, so the plates should move together. In 1997, Steve Lamoureux at the University of Washington measured this effect with exquisite precision. The plates attracted each other exactly as Casimir predicted. The darkness between them had less energy than the darkness around them, and that difference created immeasurable force. This was proof. Darkness has energy. The vacuum, the void, the nothing, it's not passive. It's active. It pushes and pulls. It creates and destroys. Darkness is a thing. Now let me blow your mind with the implications. If the vacuum of space has energy, that means darkness has energy. And if darkness has energy, then Einstein's equation EE equals mc tells us that darkness has mass. Not much. The vacuum energy density is incredibly small, but it's not zero. The darkness in your room right now has mass. The void between stars has mass. In fact, this vacuum energy might be what we call dark energy, the mysterious force accelerating the expansion of the universe. If that's true, then darkness isn't just older than light. Darkness is the dominant force shaping the evolution of the cosmos. But here's where it gets really weird. In quantum mechanics, particles aren't really particles. They're excitations in quantum fields. An electron is an excitation in the electron field. A photon is an excitation in the electromagnetic field. And the ground state of these fields, the state when there are no excitations, no particles, that's darkness. Light is what happens when the electromagnetic field gets excited. Darkness is the ground state, the baseline, the natural state of reality. Light is the deviation. Think of it like this. Imagine reality is a trampoline. The flat trampoline is darkness. When you jump on it, creating dips and waves, that's light and matter. But the trampoline wants to be flat. It always pulls back toward flatness, toward darkness. Every particle, every photon, every excitation is fighting against the fundamental tendency of reality to settle into the dark ground state. And here's your fifth mind-blown moment. In quantum field theory, The vacuum state, a state of perfect darkness, has the lowest possible energy, but that energy isn't zero. It's called the zero-point energy, and it's the energy that remains even when you've removed all possible energy from a system. You can't get rid of it. Even at absolute zero temperature, quantum fields still fluctuate. Even in perfect darkness, there's irreducible energy. Darkness isn't zero. Darkness is the minimum possible non-zero. Now let's talk about black holes again, because they're the universe's ultimate laboratories for understanding darkness. When a star collapses into a black hole, it creates a region of space-time where gravity is so strong that light cannot escape. The event horizon is the point of no return once light crosses it. It's trapped forever. From the outside, a black hole looks perfectly black, perfectly dark. But Stephen Hawking showed in 1974 that black holes aren't perfectly black. They emit radiation. Here's how it works. Remember those virtual particle pairs popping in and out of existence in the vacuum? Near the event horizon of a black hole, something strange happens. A particle-antiparticle pair appears. Normally, they'd annihilate each other almost immediately. But if one falls into the black hole while the other escapes, the escaping particle becomes real. It doesn't annihilate. It flies away as Hawking radiation. The black hole loses a tiny bit of mass. And here's the kicker. This radiation comes from the darkness around the black hole. The vacuum, the void, is creating light by stealing energy from the ultimate dark object. Black holes evaporate. Slowly a black hole, the mass of the sun, would take 1,067 years to evaporate completely, but inevitably. And as they shrink, they evaporate faster and faster until they explode in a final burst of radiation. Every black hole will eventually turn itself into light and disappear. The darkest objects in the universe self-destruct through the quantum properties of darkness itself. But here's what's truly mind-bending: the information paradox. Quantum mechanics says that information cannot be destroyed. When you burn a book, the information isn't destroyed. It's encoded in the smoke, the ashes, the photons of heat. It's scrambled, but it's there. But when something falls into a black hole, and the black hole evaporates, where does the information go? Hawking radiation is thermal. It's random. It carries no information about what fell in. So the information would be destroyed, violating quantum mechanics. This paradox has tormented physicists for decades. The resolution, according to current thinking, involves something called the holographic principle. The idea is that all the information about the three-dimensional volume inside a black hole is encoded on its two-dimensional surface, the event horizon. And when the black hole evaporates, that information is released in subtle correlations in the Hawking radiation. The darkness on the surface of the black hole contains all the information about everything that fell in. This leads to a radical idea. Maybe all of three-dimensional space is like the inside of a black hole. Maybe all the information about our universe is encoded on a two-dimensional boundary, incredibly far away, and we're just experiencing a holographic projection. The depth, the solidity, the three-dimensionality you perceive it might all be an illusion. The real universe might be a two-dimensional darkness, and everything you experience is just patterns on that dark surface. This isn't science fiction. This is serious theoretical physics being explored by people like Juan Maldacena and Leonard Susskind. The holographic principle suggests that reality is fundamentally two-dimensional and dark, and the three-dimensional world of light and matter is emergent, derived, illusory. If this is true, then darkness isn't just older than light. Darkness is more real than light. Let me tell you about another experiment that reveals the strangeness of darkness. In 2015, researchers at MIT created what they called temporal darkness, brief moments where light is forbidden from existing. They used a technique called time refraction, sending a pulse of light through a special material that temporarily changed its refractive index. For a brief moment, the material created a gap in time where the light couldn't propagate. They created a bubble of darkness that moved through the light beam, a dark pulse in a sea of light. This demonstrated something profound. Darkness can be created, manipulated, controlled. It's not passive. You can make structures out of darkness, just like you can make structures out of light. In fact, metamaterial scientists are now creating dark light beams that carry darkness instead of brightness, antiphotons that cancel out light. The boundary between light and darkness is getting blurrier the more we study it. Now let's talk about something that will make you uncomfortable. Your brain evolved to avoid darkness. For millions of years, darkness meant danger. Predators hunted at night. Falls, injuries, getting lost, all more likely in darkness. Your ancestors who feared the dark survived to reproduce more often than those who didn't. You carry genes that make you uneasy in darkness. That anxiety you feel in a dark room? That's evolution. That's your ancestors' terror encoded in your DNA. But here's the thing, that fear is based on a misunderstanding. Darkness doesn't hide predators. Darkness is just the absence of the light you need to see the predators that were always there. The danger isn't the darkness. The danger is your temporary blindness. And in the modern world, that fear is obsolete, yet it persists. We light our cities so brightly that most people have never experienced true darkness. Light pollution is so severe that 80% of humans live under sky glow. Most people have never seen the Milky Way, the galaxy we live in, because there's too much artificial light. We're so afraid of darkness that we've banished it from human experience. And in doing so, we've cut ourselves off from something fundamental. Ancient peoples understood darkness. They sat with it, accepted it, found meaning in it. Every culture has myths about the primordial darkness from which creation emerged. The Greeks had Erebus, the personification of darkness born from chaos. The Egyptians had Kek, the god of darkness who existed before light. The Hindu tradition speaks of the cosmic night of Brahma, periods of billions of years when the universe dissolves back into darkness between cycles of creation. These aren't just myths. They're intuitions about the nature of reality that modern physics is confirming. Darkness is the ground state. Darkness is the default. Darkness is what was, what is in most places, and what will be again. Are you still with me? We're about 90 minutes in, and we've covered quantum mechanics, black holes, the holographic principle, and the evolutionary psychology of darkness. If your mind is swimming in strange new ideas, perfect. That's where the best learning happens. If you haven't subscribed yet, do it now. We're about to shift gears and talk about what all of this means for you personally, for your place in the universe, for your understanding of existence. Let me leave you with a thought before we move to the next section. Every night when you go to sleep, you close your eyes and experience darkness. In that darkness, you lose consciousness. Your sense of self dissolves. You stop existing as a conscious entity for hours at a time. And yet you're not afraid because you trust you'll wake up. But what if you don't? What if one night the darkness is permanent? At some point, for every conscious being that has ever existed, the darkness becomes permanent. Death is the return to darkness, not metaphorical darkness. Actual, literal darkness, the cessation of the electromagnetic signals in your neurons that create the light of consciousness. Hold that thought. In the next section, we're going to explore the philosophy and metaphysics of darkness. And we're going to discover that some of the deepest thinkers in human history have grappled with exactly these questions. And their answers might surprise you. We need to talk about nothing. Not the everyday nothing of there's nothing in the fridge, but the philosophical nothing, the ontological nothing, the void. Because when we ask whether darkness is older than light, we're really asking a deeper question. Is nothing more fundamental than something? Is non-existence more basic than existence? And this question has occupied philosophers for thousands of years. Let's start with Parmenides, a Greek philosopher from the 5th century BCE. Parmenides made a radical argument. Nothing cannot exist. His reasoning was elegant and maddening. For something to exist, it must be. But nothing, by definition, is not. Therefore, nothing cannot be. The void, he argued, is impossible. What appears to be empty space must be filled with something, even if we can't perceive it. Parmenides was wrong about many things, but his intuition that empty space is filled with something? That's exactly what quantum field theory confirms, 2,500 years later. The vacuum is full of quantum fields and virtual particles. Nothing cannot exist. But if nothing cannot exist, then what is darkness? If darkness is defined as the absence of light, and absence is a form of nothing, and nothing cannot exist, then darkness cannot exist either. But we perceive darkness. We experience it. So what are we experiencing? This is where the philosopher Leibniz comes in with a question that has haunted philosophy and physics ever since. Why is there something rather than nothing? This is called the primordial existential question. Think about it deeply for a moment. Existence requires no explanation if it's necessary, if reality couldn't be any other way. But it seems like nothingness should be the default. Nothing is simpler than something. Nothing requires no cause, no creation, no explanation. Something demands all of those things. So why does anything exist at all? And here's where it connects to our question about darkness and light. If we replace nothing with darkness and something with light, we get, why is there light rather than darkness? And suddenly the question seems answerable. There is light because stars exist. Stars exist because gravity collapsed gas clouds. Gas clouds exist because of quantum fluctuations in the early universe. We can trace the causal chain. But at the end of that chain, we hit the Big Bang. And before the Big Bang, darkness? Nothing? The question remains. Let me introduce you to a modern philosopher who grappled with this, Martin Heidegger, who wrote extensively about what he called Das Nichts, the nothing. Heidegger argued that we encounter nothing not as an absence, but as a presence. When you stand at the edge of a cliff and feel vertigo, that's not just fear of falling. It's the presence of the nothing, the void reaching up to you. When you experience profound anxiety about existence itself, that's encountering the nothing. And here's his key insight. We can only understand being, understand existence, by contrasting it with nothing. Darkness makes light meaningful. The void makes existence significant. In Eastern philosophy, this gets even more interesting. Buddhism speaks of unyad, usually translated as emptiness or voidness. But unyad doesn't mean nothingness in the Western sense. It means the absence of inherent existence. The idea that nothing exists independently, that everything is interdependent and empty of permanent, separate self-nature. The Heart Sutra, one of the most important Buddhist texts, states, "Form is emptiness, emptiness is form. Light is darkness, darkness is light." They're not opposites, they're interdependent. The Tao Te Ching, written by Laozi around 400 BCE, opens with a profound meditation on darkness and light. The Tao that can be told is not the eternal Tao. The name that can be named is not the eternal name. The nameless is the beginning of heaven and earth. The named is the mother of 10,000 things. The nameless, the void, the darkness, that's the source. The named, the formed, the light that's the manifestation. Darkness is the mother. Light is the child. These ancient texts are describing something that modern physics confirms: the quantum vacuum, the dark energy field, the zero-point fluctuation. These are the nameless source from which particles, light, and forms emerge. The mystics knew it through meditation. The physicists know it through equations. The answer is the same. Darkness is fundamental, and light emerges from it. Now let's talk about information theory, because it connects to this in a mind-bending way. Claude Shannon, the father of information theory, defined information as a reduction in uncertainty. When you receive a message, you gain information because it narrows down the possible states of reality. Now here's the key. Maximum information corresponds to maximum uncertainty before the message. And what is maximum uncertainty? It's a state where all possibilities are equally likely, a state of perfect darkness, metaphorically speaking, where you can't see what's true. The philosopher and physicist John Archibald Wheeler proposed it from bit, the idea that existence itself emerges from information. Every physical quantity, every particle, every property of the universe ultimately derives from yes or no questions, from bits of information. And what is the ground state of information? Zero. Darkness. The absence of information is the baseline, and information light, in our metaphor, is what we build on top of it. But here's where it gets weird. Information cannot be destroyed, but it can be hidden. When something falls into a black hole, the information isn't destroyed, it's encoded on the event horizon. The information falls into darkness, literal darkness, but it's not lost. It's hidden. This suggests something profound. Darkness is where information goes, but not where it ceases to be. Darkness is the library of the universe, the archive of everything that ever was. Let me tell you about a thought experiment called Boltzmann brains. Ludwig Boltzmann, the founder of statistical mechanics, realized something disturbing. In an infinite universe, or given infinite time, random quantum fluctuations could spontaneously create anything, including a fully formed brain with all your memories, appearing for one instant before dissipating. The probability is incredibly low, but in an infinite universe, incredibly low probabilities become certainties. Here's the disturbing part. In the far future, in the dark era of the universe, when all stars are dead and the universe is cold and dark, Boltzmann brains will eventually become the most common form of consciousness, more common than evolved consciousness from living beings. The vast darkness will occasionally, randomly, spontaneously generate conscious minds that exist for a moment and then dissolve back into darkness. This means that your consciousness is more likely to be a random fluctuation in the darkness than a product of evolution. You're more likely to be a Boltzmann brain, a hallucination that the darkness is having right now, than a real person reading this. Your entire history, your memories, your world, it could all be false, generated 1 second ago by random quantum fluctuations in a dead, dark universe. I know that's disturbing. You can be reasonably confident you're not a Boltzmann brain, because brains are more likely to be minimal, just a brain, not a brain in a body in a world with other people. But the fact that it's even possible that darkness plus infinite time can generate consciousness from nothing tells us something profound. Consciousness might not require light, stars, or life. It might emerge from darkness itself, given enough time. Now let's talk about perception and consciousness more directly. Your entire experience of light is happening in darkness. When photons hit your retina, they're absorbed and destroyed. They trigger electrical signals that travel through the optic nerve to your visual cortex. And there, in the absolute darkness of your skull, your brain constructs the experience of vision. You have never directly experienced light. You've only experienced your brain's interpretation of electrochemical signals caused by light. The philosopher John Locke distinguished between primary qualities, properties that objects really have, like extension and mass, and secondary qualities, properties that exist only in perception, like color and sound. And here's the thing. Light as you experience it, the brightness and color, is a secondary quality. It exists only in your mind. The electromagnetic radiation hitting your eyes doesn't have color or brightness. Those are categories your brain invents to organize sensory data. So when you experience darkness, what are you experiencing? Some argue you're experiencing nothing, the absence of visual stimuli. But neuroscience suggests otherwise. When your eyes are in darkness, your visual cortex is still active, still processing, still creating. You experience darkness as a positive sensation, not mere absence. In experiments where people are placed in absolute darkness for extended periods, they report vivid hallucinations, Their brains create elaborate visual experiences from nothing. This suggests that consciousness itself might be fundamentally dark. The default state of consciousness is something, not nothing. When you're in sensory deprivation, your mind doesn't shut off, it creates experiences. The darkness of your inner mental space is always generating potential experiences, and sensory input from light merely constrains and shapes those experiences. Light doesn't create your visual experience. It sculpts the visual experience that consciousness generates from darkness. Let me introduce you to Thomas Nagel's famous thought experiment. What is it like to be a bat? Nagel argued that consciousness has an irreducible subjective quality. There is something it is like to be you, and that subjective experience cannot be fully explained by objective physical descriptions. Now, what is it like to be darkness? This sounds absurd, but consider. If consciousness can emerge from complexity, and if the quantum vacuum is incredibly complex, seething with virtual particles and possibilities, then might there be something it is like to be the vacuum? Might darkness have an inner experience? This is panpsychism, the idea that consciousness is a fundamental feature of reality, present in some form, even in simple systems. It's a fringe idea in philosophy, but it's gaining traction. Some physicists and philosophers argue that consciousness can't emerge from purely unconscious matter, so it must be fundamental, like mass or charge. And if consciousness is fundamental, then it's present in the quantum fields, in the vacuum, in the darkness. If panpsychism is true, then the darkness isn't just older than light, it's conscious. The primordial darkness that existed before the Big Bang, if there was such a thing, wasn't just empty void. It was a form of consciousness. And every conscious mind that has ever existed is the darkness becoming aware of itself through temporary, localized complexity. This connects to another ancient idea, the Hindu concept of Brahman, the ultimate reality, the ground of all being. Brahman is described as neti neti, not this, not that. It cannot be described by what it is, only by what it is not. It is beyond light and darkness, beyond existence and non-existence. But in its unmanifest form, before creation, Brahman is pure potential, pure possibility, much like the quantum vacuum, the dark field of zero-point energy. And then there's the Kabbalistic idea of Ein Sof, the infinite, the boundless, the nothing from which God and creation emerged. In Kabbalistic cosmology, before creation, there was only Ein Sof, a darkness so complete that it transcended darkness. And from this darkness, God contracted, creating a space in which light and creation could exist. This is called Tzimtzum, the contraction. God made room for the universe by withdrawing into the infinite darkness. These mystical traditions are describing the same thing quantum cosmology describes: a pregnant void, a dark potential from which reality emerges. Darkness isn't the absence of God, or meaning, or purpose. Darkness is the womb of all those things. Are you feeling the weight of these ideas? The way they connect ancient wisdom with modern physics, consciousness with cosmology, existence with void? If you are, you're exactly where you should be. Hit that like button if this philosophical journey is resonating with you. We're going to bring all of this together soon. But first, we need to talk about what this means for you, personally, right now, in your life. Let me give you your sixth mind-blown moment. You are darkness. Not metaphorically, literally. Your body is made of atoms, and atoms are mostly empty space. The nucleus of an atom is about 100,000 times smaller than the atom itself. If an atom were the size of a football stadium, the nucleus would be a marble at the center, and the electrons would be tiny gnats in the outer seats. Everything in between? Empty, dark, void. You are 99.9999999% darkness, held together by electromagnetic forces. And it gets weirder. The particles that make up the atoms, the electrons, protons, neutrons, they're not solid either. They're excitations in quantum fields, wave functions that collapse when observed. You're not made of stuff. You're made of patterns in the void, temporary structures in the darkness, information encoded in the quantum fields. You are darkness dreaming that it is light. In the next section, we're going to explore the future, your future, humanity's future, the universe's future. And we're going to discover that our relationship with darkness is about to change in ways that will challenge everything we think we know about existence. But first, take a moment, look around, really see the light in your space. Understand that it's temporary, precious, and ultimately doomed. And feel the darkness behind it, patient and eternal. Now let's talk about time, because when we ask, is darkness older than light? We're assuming time works the way we think it does. But what if it doesn't? What if time itself emerges from darkness? According to relativity, time is not absolute. It's relative to the observer, flexible, stretchable. Near a black hole, time slows down relative to distant observers. At the event horizon, time effectively stops, at least from the perspective of someone watching from far away. An object falling into a black hole appears to freeze at the event horizon, never quite crossing it, frozen in time forever. And on the other side of the event horizon, inside the darkness of the black hole, time and space swap roles. The singularity at the center isn't a place, it's a moment in time, a moment in the future that you cannot avoid once you've crossed the horizon. Time emerges from the structure of space-time, and space-time might emerge from something deeper quantum entanglement, information, or fields we don't yet understand. Carlo Rovelli, one of the founders of loop quantum gravity, argues that time is not fundamental. Time is an emergent property of the universe, like temperature or pressure. At the deepest level of reality, there is no time. There is only a timeless quantum foam, a dark substrate from which the illusion of time emerges. If time is emergent, then asking whether darkness is older than light is like asking whether wetness is older than water molecules. The question assumes a framework time that might not be fundamental. In the timeless darkness before the Big Bang, there was no before. There was no time in which darkness could be old. Darkness simply was timelessly, and then time began, and with it, the possibility of change, of light, of events. This connects to something called the block universe interpretation of relativity. In this view, the past, present, and future all exist equally. The passage of time is an illusion created by consciousness moving through a static four-dimensional structure. Every moment that ever was or will be exists simultaneously in the block. And in that block, most of it is darkness. The events involving light, involving stars and consciousness, occupy a tiny fraction of space-time. The block universe is a vast darkness with sparse, scattered moments of light. Now let's talk about entropy and the arrow of time. The second law of thermodynamics states that entropy disorder always increases in a closed system. This creates an arrow of time, a directionality. The past is the low entropy state. The future is the high entropy state. And what is maximum entropy? It's the heat death of the universe, the state of perfect darkness, where all energy is evenly distributed and no work can be done, no change can occur. The arrow of time points from light to darkness. Time flows from the low entropy, Big Bang state of immense order and energy concentration, toward the high entropy heat death, a state of perfect darkness and equilibrium. Time is the journey from light to darkness. The future is dark. The past is, well, that's the mystery. Why was the early universe so ordered? Why was entropy so low? This is called the past hypothesis, and we don't have a good answer. But here's a possibility. Maybe the Big Bang wasn't the beginning. Maybe it was a bounce, a transition from a previous universe that had reached heat death. In cyclic models of cosmology, universes expand, reach heat death, and then somehow restart. The final darkness of one universe becomes the initial conditions of the next. If this is true, darkness is eternal, and universes are temporary fluctuations in an infinite dark background. Let me tell you about Roger Penrose's conformal cyclic cosmology in more detail, because it's one of the most beautiful and strange ideas in modern physics. Penrose realized that in the infinite future, when the universe has reached heat death, all matter will have decayed or been absorbed into black holes, and all black holes will have evaporated. What's left is a universe filled only with photons, massless particles, traveling at the speed of light. Here's the weird part. For a photon, traveling at the speed of light, time doesn't pass. From a photon's perspective, it is emitted and absorbed instantaneously, even if billions of years pass for stationary observers. In a universe filled only with photons, there are no stationary observers. There's no one and nothing to experience the passage of time. Time becomes meaningless. And in relativity, a universe with no sense of time and infinite size is mathematically identical to a universe with a sense of time and infinitesimal size. The infinite, timeless, dark future of one universe is the same as the tiny, hot, dense beginning of the next universe. The end is the beginning. Darkness gives birth to light, which ages and dies back into darkness, which gives birth to light again eternally. If Penrose is right, then darkness isn't just older than light, it's both older and younger, both before and after, both womb and tomb. Darkness is the eternal cycle itself. Now let's bring this to something more personal and immediate. You experience time as flowing from past to future. You remember the past, you anticipate the future. But here's something neuroscience has discovered. Your experience of now is actually a construction. Your brain receives sensory inputs at different speeds. Visual information arrives faster than auditory information, which arrives faster than touch. Your brain synchronizes these inputs, creating the illusion of a unified now. The present moment is a fabrication, a story your brain tells you. And when you close your eyes and sit in darkness, your sense of time changes. Without visual input, without the changing light that helps your brain track time, minutes can feel like hours or seconds. Darkness distorts time. In sensory deprivation experiments, people quickly lose their ability to estimate time accurately. The darkness reveals that time, as you experience it, is not objective reality, it's a construct of your conscious mind. Here's a thought experiment. Imagine you could experience all of time at once, like the block universe suggests might be the true nature of reality. You would perceive every moment of your life simultaneously. Your birth, your childhood, this moment reading the script, your death. All equally present, all equally real. From that perspective, the periods of darkness would vastly outnumber the periods of light. Before your birth, darkness. After your death, darkness. The brief candle flame of consciousness in between. From a timeless perspective, you are mostly darkness. But that's not depressing, it's profound. It means that the light of your consciousness, brief as it is precious beyond measure. Every moment of awareness is a victory against the overwhelming tendency of the universe toward darkness and equilibrium. Let me tell you about a man named Andres Segovia, a classical guitarist who lived to 94. Near the end of his life, he was asked if he was afraid of death. He said, "I was dead for billions of years before I was born, and it never bothered me once." This is a profound refrain. You've already experienced non-existence, the infinite darkness before your birth. And it wasn't painful. It wasn't scary. It just was. Or rather, it wasn't. And the darkness after death will be the same. Not a tragedy, just a return to the default state. But here's the beautiful part. You are the universe becoming conscious of itself. You are the darkness opening its eyes. Every thought you have, every moment of awareness, is the universe doing the most improbable thing possible, organizing energy and matter into a configuration complex enough to contemplate its own existence. You are stardust contemplating stars. You are darkness contemplating light. Carl Sagan said, "We are a way for the cosmos to know itself." But let me update that for what we've learned. You are a way for the darkness to know itself. The eternal, fundamental darkness of the quantum void has configured itself into a pattern that can think, feel, love, and wonder. The darkness has become conscious in you. And when you die, you don't become nothing. You return to being everything. The atoms in your body will disperse. They'll become soil, air, water. Some might become part of other living things. Some might be ejected from Earth and drift through space. In the far future, they'll be pulled into stars or black holes. They'll be recycled through stellar nucleosynthesis or quantum evaporation. Your matter will persist until the heat death of the universe, and if Penrose is right, beyond. You are a temporary pattern in the eternal darkness, and that pattern is unique. No configuration of atoms has ever been you before, and none will ever be you again. You are a note played once in the infinite symphony of darkness and light, and then the note ends, but the music continues. Are you still with me? We're nearly 2 hours in. We've covered physics, philosophy, cosmology, consciousness. We've traced darkness from the quantum vacuum to the heat death of the universe, from ancient mysticism to cutting-edge theoretical physics. If you're still here, you're the audience I'm looking for, someone willing to grapple with deep questions, to sit with uncertainty, to expand their understanding of reality. Make sure you're subscribed, because we're about to bring all of this together and ask the ultimate question: what should you do with this knowledge? But first, one more section on the practical implications of darkness. How is our understanding of darkness changing technology, science, and our future? Because it's not just abstract philosophy, it's the cutting edge of human innovation. In the next section, we're going to talk about dark sky preserves, the astronomy of darkness, metamaterials, quantum computing, and how our relationship with darkness is about to fundamentally change. And then, finally, we're going to answer the question definitively: is darkness older than light? And the answer is going to satisfy you in ways you don't expect. Let's talk about how humans are technologically engaging with darkness in revolutionary ways. Because our understanding of darkness isn't just changing philosophy, it's changing what we can build, what we can see, and what we can do. First, let's talk about telescopes. The history of astronomy is the history of capturing light from ever more distant sources. But in the last few decades, we've realized that to see light clearly, we need darkness. Light pollution, the glow of cities, streetlights, cars has made it impossible to see the night sky from most places on Earth. In 1994, when the Northridge earthquake knocked out power in Los Angeles, emergency services received calls from panicked residents reporting a strange giant silver cloud in the sky. It was the Milky Way. They'd never seen it before. This light pollution isn't just aesthetic, it's scientific. Astronomers have lobbied for dark sky preserves, areas with minimal artificial light. The Mauna Kea Observatory in Hawaii, the Atacama Desert Observatory in Chile, the South African Astronomical Observatory, these are some of the darkest places on Earth, and that's why they're ideal for observation. Darkness is a resource, one we're losing rapidly. But we're also creating artificial darkness in new ways. The James Webb Space Telescope, launched in 2021, operates in the infrared spectrum and needs to be incredibly cold to function. So cold that it operates in the darkness of space far from Earth, at the L2 Lagrange point, shielded from the sun by a tennis court-sized sunshield. It's creating artificial darkness to see light from the edge of the observable universe, from the first galaxies that formed after the Big Bang. We're using darkness as a tool to see deeper into the past, to see closer to the moment when light was born. And then there are gravitational wave detectors, like LIGO, the Laser Interferometer Gravitational Wave Observatory. In 2015, LIGO detected gravitational waves for the first time, ripples in space-time caused by two black holes colliding 1.3 billion years ago. These detectors don't measure light, they measure darkness. They measure the distortion of empty space itself. When a gravitational wave passes through Earth, it stretches and compresses space by an infinitesimal amount, and LEGO measures that change. We're using darkness empty space as a sensor to detect events involving the darkest objects in the universe. Now let's talk about quantum computing, because it's fundamentally about darkness. Classical computers use bits that are either 0 or 1, on or off. Quantum computers use qubits that can be in superposition both 0 and 1 simultaneously. And here's the thing, maintaining superposition requires absolute isolation from the environment. Any interaction with the outside world, any stray photon, any thermal vibration, destroys the superposition in a process called decoherence. So quantum computers are operated in the darkest, coldest conditions we can create, near absolute zero temperature, in chambers isolated from all electromagnetic radiation, in profound darkness. The computations happen in the dark, in the quantum realm where classical logic breaks down and probabilistic logic rules. We're using darkness, the quantum vacuum, the ground state, to perform calculations impossible for classical computers. And these quantum computers might help us understand darkness better. One of the biggest unsolved problems in physics is the cosmological constant problem. Quantum field theory predicts that the vacuum, the energy of darkness, should be enormous, about 10,120 times larger than what we observe. This is the worst prediction in the history of physics. Something about our understanding of the quantum vacuum is deeply wrong. Quantum computers might help us simulate quantum fields in ways classical computers can't, potentially revealing what we're missing. Let me tell you about dark matter detectors. Remember, dark matter makes up 85% of the matter in the universe, but we don't know what it is. Physicists have built detectors deep underground, in old mines, under mountains, to shield them from cosmic rays and radiation. These detectors are searching for WIMPs, weakly interacting massive particles that might pass through Earth constantly, but almost never interact with normal matter. These detectors sit in profound darkness, waiting for a dark matter particle to collide with an atom in the detector and create a tiny flash of light or heat. We're using darkness to hunt for darkness, hoping for a brief flash that will reveal the substance that outweighs all the visible universe. And so far, nothing. The detectors sit in the dark, silent, waiting. The darkness keeps its secrets. But we're also creating new forms of darkness technologically. Vantablack, which I mentioned earlier, absorbs 99.965% of visible light, but scientists have created even darker materials. In 2019, MIT engineers created a material that absorbs 99.995% of visible light. It's made of carbon nanotubes, forests of tiny tubes, packed so densely that light enters the gaps between tubes and bounces around until it's absorbed, never escaping. When you coat an object in this material, it becomes a void. You can't see any detail, any contour. It looks like a flat, black hole in reality. Artists have used this material to create sculptures that confuse and disturb viewers. Your brain can't process what it's seeing because there's no visual information. It's artificial darkness, so complete it breaks perception. And we're developing metamaterials materials engineered at the nanoscale to have properties impossible in nature. Some metamaterials can bend light around objects, creating invisibility cloaks. They work by creating a region of optical darkness. Light flows around the region without entering it, making anything inside undetectable. We're sculpting darkness, shaping it, using it as a tool. In medicine, we're learning to use darkness too. Photodynamic therapy treats cancer by injecting light-sensitive drugs that accumulate in tumors. When exposed to specific wavelengths of light, the drugs produce reactive oxygen that kills cancer cells. But to work, the body has to be in darkness first. The drugs need time to accumulate without being activated by ambient light. Darkness is part of the treatment. And in neuroscience, we're discovering that darkness is essential for brain health. Exposure to light at night disrupts circadian rhythms, leading to sleep disorders, depression, and cognitive decline. The human brain evolved in an environment of natural light-dark cycles. Melatonin, the hormone that regulates sleep, is produced in darkness and suppressed by light. By flooding our environment with artificial light 24/7, we're disrupting millions of years of evolutionary adaptation. There's a growing movement in architecture and urban planning to preserve darkness. Dark Sky International advocates for lighting designs that minimize upward light pollution. Some cities have implemented lights-out policies for skyscrapers during bird migration seasons. We're slowly recognizing that darkness isn't the enemy. It's a necessary counterpart to light, essential for ecology, health, and understanding the universe. Here's your seventh mind-blown moment. In the far future, if humanity or its descendants survive, we might become a civilization of darkness. As stars burn out and the universe cools, future civilizations will need to conserve every bit of available energy. They might operate at the edge of thermodynamic efficiency, running on the faint energy of black hole evaporation or dark matter annihilation. They'll exist in near total darkness, thinking slow thoughts over billions of years, making every photon count. Freeman Dyson explored this in his paper, Time Without End. He calculated that civilizations could continue indefinitely by hibernating for exponentially longer periods, waking briefly to think and gather resources, then hibernating again. In the deep future, consciousness might spend 99.99% of its time dormant, in darkness, waking for vanishingly brief moments of activity. But subjectively, to those conscious minds, the waking periods could be extended indefinitely. Consciousness could continue forever in the darkness, experiencing infinite subjective time in finite objective time. This means the future might contain more consciousness than the past, just spread incredibly thin across vast darkness. The darkness won't be empty. It'll be full of dormant minds, sleeping giants waiting for the rare moment when there's enough energy to think another thought. Now let's talk about interstellar travel, because it's fundamentally about crossing darkness. The distance between stars is vast. The nearest star, Proxima Centauri, is 4.24 light-years away. With current technology, reaching it would take tens of thousands of years. The space between stars is empty, dark, cold. Any civilization that ventures into interstellar space will spend most of its journey in profound darkness, far from any star. Some proposals for interstellar travel involve generation ship spacecraft that travel for centuries or millennia, with multiple generations born, living, and dying on board. For the people on these ships, darkness would be normal. They'd be children of the void, born in darkness between stars, never seeing a sunset or moonrise, only the distant cold light of stars. Their psychological relationship with light and darkness would be completely different from ours. Or consider digital consciousness minds uploaded to computers. Digital minds don't need light. They could exist in complete darkness, simulating any environment they wish internally. For them, darkness would be irrelevant. They could cross the dark voids between galaxies, running on trickles of energy, experiencing rich internal lives, while externally traversing absolute emptiness. This connects to something called the dark forest hypothesis of why we haven't detected alien civilizations. The idea, popularized by science fiction author Lou Cixin, is that the universe is full of civilizations, but they're all hiding in darkness, staying silent, because any civilization that reveals itself might be destroyed by more advanced civilizations. The universe is a dark forest, and every civilization is a hunter moving silently through the darkness, afraid to make a sound. Whether or not this is true, it's a powerful metaphor. Darkness is safety. Visibility is danger. In a vast, potentially hostile universe, darkness is camouflage, protection. Light reveals you to predators and competitors. Darkness keeps you hidden. Let me bring this back to you personally. Right now, in your life, You probably see darkness as something to eliminate. You turn on lights when it gets dark. You avoid dark places. You might even sleep with a night light. But what if you reframe darkness as something valuable, something to preserve and experience? Try this tonight, or whenever you next have the opportunity. Go somewhere dark. Not just a dark room, but truly dark, far from city lights. A park, a forest, a beach. Let your eyes adjust for 20 minutes. Don't use your phone. Just sit in the darkness and look up. If you're lucky enough to be somewhere with minimal light pollution, you'll see thousands of stars. You'll see the Milky Way, a river of light across the sky. You'll see planets, satellites, maybe meteors. And you'll see the darkness between the stars, the vast, empty, real darkness of space. That darkness is the same darkness that existed before the first stars. It's the same darkness that will exist after the last stars die. And you're a tiny, temporary spark of light and consciousness looking out into that infinite dark. And here's what I want you to feel. Not fear, but belonging. You come from that darkness. The atoms in your body were forged in stars that died billions of years ago, collapsing into darkness before exploding in seeding space with heavy elements. You are darkness that has temporarily organized itself into complexity, and one day you'll return to it, not as a tragedy, but as a homecoming. Are we near the end of our journey together? Almost. We've covered so much: quantum mechanics, cosmology, philosophy, consciousness, technology, the future. We've seen darkness from every angle. And now, finally, it's time to answer the question definitively. Is darkness older than light? But before I give you the answer, I want you to think about what you've learned. Not just the facts, but the feeling, the sense of the vastness of darkness, the brevity of light, the preciousness of consciousness. Hold that feeling. We're going to use it. If this journey has been meaningful to you, if you felt that sense of awe and understanding, hit that like button, subscribe to the channel, and share this with someone who thinks deeply, who questions, who wonders. Because the world needs more people willing to sit with big questions. Now, let's answer the question. Is darkness older than light? Here's the definitive answer, synthesized from everything we've explored. Yes and no, and the question is more profound than it appears. Yes, darkness is older than light in the following sense. The quantum vacuum, the ground state of reality, the zero-point energy field, this is fundamental. It exists even in the absence of particles and photons. Before the first light could propagate freely, 380,000 years after the Big Bang, the universe existed in a dark state. And before the Big Bang itself, if there was a before, there was likely a state of quantum nothing, a dark potential from which our universe emerged. In this sense, darkness is primordial. Light is emergent, contingent, created. Darkness is the default state of the quantum fields. Light is an excitation, a deviation, a temporary configuration of energy. Thermodynamically, entropy drives everything toward equilibrium, toward the heat death, toward darkness. Light is the low entropy anomaly. Darkness is the high entropy destiny. No, darkness is not older than light in the following sense. If we define darkness simply as the absence of photons, then darkness and light are complementary. You can't have absence without the possibility of presence. Darkness without light is meaningless. They're interdependent concepts, like up and down, before and after. In this view, neither is older. They emerge together as a pair of opposites. Furthermore, in certain interpretations of quantum cosmology, the Big Bang represents the creation of time itself. Before the Big Bang, there was no before, no time in which darkness could be old. The question assumes a temporal framework that might not apply. Darkness isn't older than light because older requires time, and time began with the universe. But here's the deeper truth. The question, is darkness older than light, is really asking, What is the fundamental nature of reality? And the answer is profound. Reality is fundamentally dark in the sense that it's fundamentally potential, probabilistic, quantum. The darkness we experience, the absence of light, is a local, classical manifestation of a deeper quantum darkness that seethes with possibility. Light is what happens when that possibility collapses into actuality, when the wave function becomes a particle, when the field becomes excited. Darkness is the infinite potential. Light is the finite actual. And in that sense, yes, darkness is more fundamental, more eternal, more real than light. Let me synthesize this with a metaphor. Imagine the universe as an infinite dark ocean. Waves rise on that ocean. These are particles, photons, light, matter. The waves are real, they exist, they have effects. But they're temporary patterns in the ocean. The ocean is eternal. The waves come and go. The ocean is darkness. The waves are light. You are a wave. Consciousness is a wave. Every star, every galaxy, every civilization waves. Some last microseconds, some last trillions of years. But all waves eventually merge back into the ocean. The darkness is patient. It has all the time in the universe, literally, to reclaim everything. But here's the beautiful part. While the wave exists, it's distinct. It has individuality, complexity, meaning. The wave can know itself, can know the ocean. You can contemplate the darkness from which you came and to which you'll return. That contemplation, that awareness, it's the universe knowing itself. It's the darkness opening its eyes. So is darkness older than light? Ultimately, the answer is, darkness is fundamental, eternal, and patient. Light is emergent, temporary, and precious. Darkness doesn't need light, but light needs darkness to exist against. Darkness is the canvas. Light is the painting. Darkness is the silence. Light is the music. Darkness is the infinite. Light is the finite. And you, reading this right now, you are the moment when darkness becomes light, when potential becomes actual, when the universe wakes up and says, I am. Cherish that moment. It won't last forever. But while it lasts, it's the most improbable, most beautiful thing that has ever happened in your particular region of space-time. Here's my final gift to you. A reframe. You might have started this journey thinking of darkness as scary, as negative, as something to avoid. I hope you now see it differently. Darkness is rest, potential, possibility, peace. Darkness is where you came from and where you'll return. Darkness is the embrace of the universe, the womb and the tomb, the Alpha and Omega. Don't fear the darkness. Don't fight it. Understand it, respect it, even love it, because the darkness is you. The eternal, fundamental quantum darkness that underlies all of reality. That's your deepest nature. You're not a being of light trapped in darkness. You're darkness that has briefly, gloriously, and possibly become light. And when your light goes out, as all lights eventually do, you're not disappearing. You're returning home. The darkness will welcome you back, and you'll merge with the infinite potential from which you came. No suffering, no fear, no loss, just the quiet peace of returning to the ground state of reality. Live your life knowing this. Be the light while you can. Shine brightly. Think, love, create, experience, wonder. Because you are the universe's brief attempt to know itself, and that attempt is sacred. But also, don't fear the darkness. Sit with it sometimes. Close your eyes, be still, and feel the darkness inside and outside you. Feel the continuity between your inner darkness and the cosmic darkness. You are older than the stars. The atoms in your body are ancient, forged in stellar furnaces billions of years ago. The quantum fields that manifest as your particles are eternal, unchanged since the beginning of time. You are young, your particular configuration exists for decades at most. But you are also old, the substance of you is timeless. Hold both truths. You are light and darkness, young and ancient, finite and infinite, individual and universal. This is the paradox of existence, and it's beautiful. Thank you for taking this journey with me. 3.5 hours exploring one question, ranging from quantum mechanics to mysticism, from the Big Bang to the heat death of the universe, from the philosophical void to the practical technology of metamaterials. If you've made it this far, you're rare. You're someone who cares about deep questions, big ideas, fundamental truth. I want to leave you with one final thought experiment. Imagine it's the far future. The last star has died. The universe is cold, dark, empty. Somewhere in that darkness, a quantum fluctuation occurs. A brief spark of energy, a temporary violation of entropy, a Boltzmann brain. For one instant, consciousness emerges from the void, experiences one thought, and dissolves back into darkness. What does that consciousness think about? Maybe it thinks about this moment right now, when you're reading these words, when light and consciousness still exist, when the universe is still young enough to be interesting. Maybe that brief consciousness in the far future looks back across the eons and feels what you should feel right now. Gratitude. Gratitude for existing in a time when existence is still possible, when the universe still has stars and minds and meaning. You are impossibly lucky to exist now, in the stelliferous era, when the universe is bright and alive. Don't waste it. Don't spend your brief life drowning in trivial concerns and petty fears. Look up at the stars. Contemplate the darkness. Think deep thoughts. Love deeply. Create meaning. Be the light while you can, because darkness is older than light. Darkness is eternal, but light is the miracle. And you are that miracle right now, reading this, thinking this, being this. Thank you for joining me on this journey. If this changed the way you see reality, share it. Talk about it. Think about it. Let it settle into your bones. And the next time you're in the dark, don't reach for the light switch immediately. Sit with the darkness for a moment. Feel its ancient presence. Remember that you came from it, and you'll return to it. And that's okay. You are darkness dreaming that you are light. Dream beautifully while you can. If this video meant something to you, please like, subscribe, and share. Drop a comment telling me what country you're from, what time it is, and whether this changed how you think about darkness. I read every comment, and your reflections matter to me. Until next time, may you shine brightly in the darkness, and may you find peace when you return to it. The darkness is older than light, but you, right now, are the light. And that's everything.